Okay. Does anybody have any thoughts about the chapter? Any questions, concerns, things you liked?
Yes. So comparing enums and structs, how they gave a few examples within chapter itself as to when you would use one or the other. I just wanted to see if we can go a little bit more in depth about, like the practicality of using one or the other. Just give me a few more examples to understand.
Okay. Yeah, I can definitely go over that.
Thank you.
Not hearing anything else, so let's get into it. So, enums are a way to group all of our related values into a single type. So, if we need something like this, we have an operation. And this way we have some issues because we don't know what a not valid operation could be without some good documentation. And even then, we don't know if the documentation is actually right. So maybe we can do other things like subtraction. And subtraction is fine, so we can do num1 minus num2, or we can do addition. And then we do the same thing. I accidentally imported something. And this is not addition. So the first thing you do in a different language would probably be doing if-else statements or a switch case, but we aren't guaranteed that it's exhaustive like with a match statement. So here it's telling me that we're not covering everything because there are a lot more strings it could be. So we need some specific case that catches everything so it's impossible to fall through. So what do we do if we have an invalid operator? Let's just throw an error for now. And then we could also replace this with something for a better error message, like just call it invalid. And that way, if we call this incorrectly, it will let us know. And right now we could do like times. And we get a better error message. Any questions so far? Okay.
One question.
Yeah, go for it.
The invalid in the match case, is that like a keyword, or can you just set that to whatever you want?
You set it to whatever you want. So if I in here, I guess I could change it to anything. So hello, that still works. It's just a binding like any other. And then the underscore is the one that does not bind anything.
Okay. But can you have like multiple like words? Could you have like hello 1 and hello 2, or can you just have like the one like catch all? I would assume.
I'm sure you could try, but you're not gonna. Yeah, you're allowed to do it. It just says, why would you do this? You can't even get to this pattern.
Even if you give it a different name.
Yeah.
It just,
I mean, these are different variables.
Hits the first one and then exits.
Yeah, like there's no way it could ever get here.
Okay.
Yeah.
Cool.
One question: this operation multiplication, it gave us error, right? It was a little bit too fast. Wasn't able to see it immediately.
Oh yeah, there's an error
Operation.
because we're currently
Exactly.
panicking. Yes.
So because you didn't put this operation in your match operation, right, where you have minus and plus, it put us an error, right? Because of that, it couldn't find it in a match operation, correct?
Well, the match will never compile if it's the case that it won't match in any case. So this will always match something, but it's only throwing an error because we said it should throw an error. We could also just do nothing or print something to the console.
Yes, but if you, for example, put like multiplication and then num1 num1 and then multiply by num2, then we wouldn't have this error because of multiplication, right? It will be some other error if you have it, correct?
Yeah, we're allowed to do num.
Exactly.
So what question are you asking?
So I'm just asking, we had two errors, right? We had operation error, right? And evaluate, you put operation multiplication, correct?
Yeah.
And we get an error that this operation is, I wasn't able to see it. What kind of error was it? If it was.
Oh, what kind of error? I just wrote out specifically invalid operator. So it is a custom error message. I specifically did
because
this.
you see it's okay, because it says invalid operator multiplication. You see it's a symbol there.
Yeah, it's a valid symbol here. Yeah. Okay. Yeah, it was just me doing
That's
it
what I meant.
there. In a better program. Like this would be like more of prototyping. You probably don't want it to throw an error here unless you feel like it's not recoverable for your program. Most likely we would use a different enum. We'd use a result enum to say this threw an error, and then the caller can decide what to do with that.
That makes sense. Okay.
So this is where enums come in to group that data. Like here we have no clue. Maybe we think it does multiplication, like it says in some documentation you can multiply, but this operator is not allowed.
Yeah, that got confused, right?
Yep.
That's why I ask. Yeah, okay.
There's no way to know, but we could also make an enum for this. So we can make an operation enum and store our variance in here. So we want subtraction, we want addition, and we want multiplication. And here, if we replace this with an operation, oh, that should not be addition, that should be subtraction. We need to replace each one of these, and it knows that these are the only ones that are allowed. Addition, multiplication. And then moving here, we have our final one, multiplication. And then we can't print this out. But here, it's happy with it. We're allowed to do this. We've told it that, oh yeah, we can't do this. It's not happy with not using an operation, but we could say, let's add these. And then at this point, it works out. If we try to call it, we can't possibly call it with a value that isn't implemented because it takes in any one of these operations. So you can't even represent an invalid state here. You can't mix up how to do multiplication or addition or any of that. Any questions here? Okay. So then someone asked earlier, why not use a struct? And if we tried to use a struct here, could anyone say why struct would be a worse fit for this? Or would it be?
I don't think a struct would really help us any more than using a string like we had originally, since you still have to define like some sort of data type for like within the struct. And so you'd be doing essentially the same thing. Like whatever values you put in the struct, you still have to like unwrap that to get to like whatever operator you passed in. So you wouldn't like get the benefit of having like the enums like type verification like when you pass stuff in, unless you essentially implement an enum with the struct, which would be weird.
Yeah, if we use a struct, we're not going to get one or the other. We would get, it would all have to be the same shape. So if we wanted to do different things in here, like store different data, I'll get into that later, but each one of these fields can store some data. So if we wanted to store like an I32 in here, we could do it and say none of the other ones require anything. Or we could give this one something different, like a string, and it doesn't complain. But there's not really a way to do that if you use a struct. So yeah, we'll get into it later, because this is not the best example for showing that off, because these are like abstract operations with nothing attached to them. Maybe we could attach functions to them, but we're not going to get into that for now. Any questions now?
Nope, not right now.
Cool. Okay, so the benefit here is matches are, or enums here, are exhaustive because we're using a match statement. And that way we don't need to worry about the case where we did something wrong, because it's just not even possible to represent that here. If we used something else, like we used if let, then maybe we'd want to handle one of these cases and not the other, but in that case we would not get the exhaustiveness of a match statement. But here, since we want to handle every case, it makes sense to leave it like this. But there is a way that our function could still have issues. So like subtraction, addition, multiplication. Is there any issues we could have there? Will this always just work fine?
Not if you add any more operations. I mean, you'd have to, like every time you add an operation, you would have to like propagate that to any matches that require it. Since you don't have a catch-all in your evaluate. Right?
What do you mean?
If you ever add like a division operation, right, then it should give you an error in the match because you're not matching every possible case.
Yep, that is true, but I was specifically talking about like carrying out the operation, so like unrelated to the enum. What could go wrong here?
Oh.
What if you have a minus? Let's say the num2 is like a -2, and you have num1 is, for example, number 1, then you would have 1 minus -2. Would that be maybe an issue?
No,
If
it
you
should
have
be
a
fine.
negative, it'll be fine. Okay.
Yeah, we could do it right now. 1 minus -2. And I'll actually print this for us. Yep, it's totally fine.
Okay.
You could have
Yeah, I
integer
thought-
overflows.
Yeah, that's what I was going for.
So like number 1 is 0 minus what is it? I32. So like 5 billion or something.
We don't need to
Would
know
overflow.
what that is. We can always just
Just to demonstrate, because it should. Will it compile if you do like a, or will it give you a runtime error if it overflows?
depends on where we're running it.
Oh, okay.
And that's a good question because we have talked about this a few times. So I'm going to put you on the spot.
Oh, great. I think it does. I feel like I've seen integer overflow runtime errors before from Rust.
We
Oh,
left it at 0. We
Nope.
should have kept it at -1. Oh, maybe I should have done I32 min. Interesting. Oh, does it? It probably just wraps at this point. Oh, there we go. I don't know why -1 did not go below. Oh, that's because I was doing.
Oh,
I don't know. I think it's because
if
min
you
goes
use
lower
if you
than
use
min
negative
max.
2, if you use -2 and then subtract by the max, does it give an
Okay,
error?
because the max is less than the
Yeah,
min.
because I think the
absolutely.
negative. So like where the boundary is, you have like one more negative number than positive number. Is probably what it is in the
Yeah.
allowed range.
And let's see, because we can just print that. Oh, well, we can't run this. Yeah, we have one
Yep.
more number. If we take absolute value, it's 1 higher.
Yep.
Okay, that makes sense. Yep, so now that we know, well, actually, I'll go over it a little bit more. So in production, it will not panic, but in debug mode, which we're doing currently, it will panic. So if I run this in release
Noted.
mode, it does not. It
just
does
overflows.
integer
and lets it
underflow.
underflow.
It's an underflow because we went below
Yeah.
like the negative. But yeah, so we could have an issue here. So we know that this operation, maybe that's what we wanted to do. Maybe we don't. I feel like underflow is typically a bug in your code. So let's just say it's always a bug. So is there some construct we could use? Maybe an enum that would represent that state? Or maybe a method that would return an enum and make sure we don't overflow.
I don't know. Does sum do that?
Is there some? I don't know what some would do on a
No,
number.
I mean SOME. Because you said enum, so I just started thinking of options and.
Sum is
stuff.
not a method on an I-32.
No, I mean the
Oh,
like
sum?
the constructor.
Oh, yeah,
But
an
I don't. That's
option.
not what you were
Okay.
talking about.
Oh, yeah, I'm talking about a method that does return options. And there's a hint that's on the screen right now. But yeah, you're right. It's an option.
Checked. I see. Checked. Add or checked. There's a bunch of checked functions.
Yep, we have checked, so we can
Oh, that's handy.
do that. And then, of course, at this point, it's a mismatch because we don't want to return an option. But what this does is... Oh, sorry about that. It subtracts and it returns none if an overflow happened. Oh, maybe that was an integer overflow. Okay, sorry about that. I was wrong.
Well, I mean, it's always referred to as an overflow because it's like overflowing a boundary, not like. I've never heard underflow.
Interesting.
Before.
Okay.
So I think that's probably just in either direction. It calls it an overflow. Would
Okay.
be my guess.
I mean, we'll see for addition. We're about to do that. Num2. Oh yeah, it says overflow for all of them. And then finally we have our checked mul. I wonder if division let's show off that we can do this. I want to see if division returns an option also. It would make sense for the API, but there's more than one way that could fail. Oh wait, there's...
checked
Is
division.
it? Yeah, because if we divide by 0, that's an issue. But also if we do something else... Like I was thinking we could divide by a small number and it would get too big. Or we could divide it too much, but it would always truncate towards 0. So I don't think that's even an issue. But yeah, we're missing division, so we can fill match arms. Amazing. Love Rust.
Well, yeah, because they're integers, like you couldn't divide by a float anyway.
Oh, I should have done num1 here. Let's see. So it does return an option, so... Okay, so it does it if it's 0 or it results in overflow. I wonder how that would happen. There's no example here. Oh well. That is a thing to check for another day. Don't want to get stuck on it. But, yeah.
Rabbit hole. Rabbit hole.
We're not getting into 2 more rabbit holes. So we are returning an option of an I-32 now. So this is the wrong type. So we have to wrap it in an option. And it already knew the return type. But this is a little bit different now because this is an option. So instead of throwing an error here, we can guarantee that this math will always work out. Well, actually, we'll know if it works out or it doesn't. And just to look at options, here's option 2. Option taken, or what are the 2 variants of option?
Hello? Hello?
Hey,
Oh, I was muted the entire time. Um, that was embarrassing. Talking to myself. Let's see. There's one that has either like no value or a null value, and the one that does take a value.
yeah, they're called none and some. So this is essentially what's happening here. We say it's obvious why this caused an error. Like for subtraction, it's because of an overflow. So you don't need to describe the error. But in a different case, like a database connection, there could be a ton of different reasons why that failed. So, but here we're just using a simple option. And that way we can say it either has nothing, and this has no data associated with it at all, or something, and it has some data in here. Which is why our function to take the value out is called unwrap, because we're unwrapping t, and if there's nothing there, then we can't do that, and it panics. But there's a lot of nice methods to work on these. Sorry, go ahead.
Or I was just saying, like T stands for tuple, so you're expecting like a specific type of data from it.
Oh yeah, t is just any type.
Oh, any type. Okay.
It can be anything we want. So like we could have
T is just like arbitrary though, right? You can put whatever letter or like even word in there as the type, right?
some of them are already used, so you can't. But a lot of, yeah, you should be fine most of the time. There's conventions, like how t is just a generic type, but there's also f for functions.
The reserved keywords you can't use and things like that.
Yeah.
Of course, yeah.
I could make some things in here, like I could still use option because it's namespace under here, or I could make my own option and it's okay, which is another great part of Rust. You can make your own result and error types if you want. And that way you don't need to deal with wrapping it every time. You can be in a database file and say, okay, I only want database errors in here. And then you don't even need to worry. This is a result that has some database error. And then you're fine. Just makes it a little bit easier. But not to get too ahead of myself. Yeah, we have either one of these. And we could also have none. But none doesn't know what type none is, so we have to tell it what type it is. So we could say this is a none that's type i32, and it's happy. Or we could do it the other way and say this is an option, and delete all of this. So we know it's either none or some, and we can match on those variants, just like how we're matching here. So if we want to use this number, print it out, we can debug it and see that this is none, but we're not going to be doing that in production. We want to do something else with it. We can match it, or if it's none, we can do nothing, but we can match X. We need both of these match arms, none and some. So we can print this out. We want to print. Oh no, I put that in the wrong spot. Our answer is val, or print out error. This is a very bad error message, but we can figure it out. So error, oh no. I don't want to know why I'm running release mode and not quiet. There we go. so we can match on either one of these things. Does that make sense so far?
Yep, good for me.
Okay. And then I probably should have gotten into option a bit more. We'll write out our option enum again. But as a struct, it makes less sense. We could make it a struct if we wanted to. But in that case, we would have sum here. And that could be either something or nothing. So how do we represent nothing? I don't know. So we could do it with an enum, just because it's easier. We could just use regular option. And then this is t. And then e for error. Or maybe we don't need that. Who knows? But we have some and we have none. So the difference here is we need to fill out some and none every time. And it's a little bit tougher. Actually, this would probably be better as unit. So like, this way we could put both of them as sum or both of them as none, and that is not what we want to do. So our enum is better here because we want one or the other every time. Does that make sense?
I'm sort of confused about the usage of an option within an option.
I was just trying to implement option with a struct, and it's like not.
It's not possible. Like
doable.
you have to use an option to do it.
I mean, we could do it
Like,
a
I think
different
an
way.
enum is the only way to do it, right? Like, because the struct doesn't allow a value to represent multiple things at a, like, do you know what I mean? Like, it has one state, whereas an enum can be one or the other, right? It's basically like a selection of possibilities, and a struct isn't that. It's just a single state with values.
A single structure, I would say, because it has a lot of different states.
Well, it has a lot of different possible states, but essentially it can only have one state at a time.
Yeah. I think we could do it like this, like you have your error and your none variant and just an empty string otherwise.
How is it
That-
how is it implemented in the in actual Rust?
Gross macros, I'm pretty sure. But let's find
Never mind.
out.
I was gonna say maybe we could just look at that, but yeah.
We're gonna
Maybe
look at it
not.
and we're gonna run away if it's scary.
Okay, I'm
Oh, okay, it's not
100%
scary.
behind this.
If we
Oh,
look
yeah.
at it in the documentation, it looks nice. Yeah, look,
Yeah.
it's like the same thing I did. But if we go to option, oh yeah, there's scary macros.
Don't scroll down. Just go back up. It's fine.
we're leaving. Goodbye. Without the macros, it's easy to read, but like, I've learned my lesson from jumping into the source code too much.
Dug too greedily and too deep.
Yeah, so now that we've gone over this a bit more and some of the benefits, or like what are some of the benefits and downsides maybe of using options for error handling instead of just like null or undefined?
I think one benefit is that you have to be explicit when you're handling errors. Like in JavaScript, when you just have null or undefined, you don't really have to worry about, like, it could be null or undefined, and then JavaScript will tend to automagically convert it to things so that the program will keep running. But in this case, whenever you have an option, right, you can't actually use the value unless you explicitly unwrap that value. So you're aware that that value needs to be handled as an error case. And maybe you can ignore it. You can just like do dot unwrap. But at least in that case, it's apparent that that's happening.
Maybe it's not. If you do it in like if I expose this to someone else and I do dot unwrap here, it might not be that clear that it's happening. It would be an anti-pattern at that point if you decided to just throw here. But you could just like default it or something too. Like there's lots of fancy methods, like we have unwrapper default or else.
Yeah, but like at least in that case, it's like, okay, well, you can do a search on your code for unwraps and find those. There's nothing you could do in JavaScript to sort of identify those sorts of things, like where values are being unwrapped from null or undefined or whatever values.
Yeah, unfortunately, JavaScript can't do those compile time checks, so we get optional chaining, and that's it.
Could you use what's it called? The result enumeration? Does that have like specific error handling?
Result is pretty much the same. It's not the same. It is structurally very similar to an option. So if we have a result, we take in two parameters. We have t and e, and we have instead okay, which has t in it, and error, which has e in it. So this is for that other case I was mentioning where it is unclear. So if we have a database connection, like I mentioned, there are tons of reasons, like network error could happen, your credentials could be wrong, many reasons why it didn't work. And it's unclear, but for adding numbers, it's clear enough that you just did something wrong. It overflowed. So yeah, I think that's fair to add in here, benefits of option and result for error handling. Anything else? I think beyond being explicit and exhaustive, it's very nice because you don't have to do multiple code paths for multiple values because it's just a variant of one thing. So you can follow a single path. So maybe we don't want to do that or do this. And instead we could do a bunch of operations, like we have x, and if it's none, we want to return none. Oh wait, that's not an option. So let's do option I32. And that's invalid. Okay, you can do results, but I've never done option. So let's do this in a different function. Or just leave it here. Oh well. But we have lots of fancy methods to do more stuff on things. So let's see, we have x here, and we can match x and handle both of these cases. So if we have the result here, we have none, we keep it none. Otherwise, we can... Sorry, it's taking me a long time for this example.
No, you're all good.
We can do sum and evaluate something else. So we want to throw res in here. And maybe we want to multiply by 10. And instead here, we will just do like 10, so we don't do this. So here, we made sure to handle both of these cases. And maybe we want to do even more in here. Like another one of these. So z is match y. And then if it is not none, let's just match it for now. So if it's none, then we can do our print. And then otherwise we can print. I wonder if this will compile. I think I need curly braces for this because I'm not returning this stuff. Oh, that is an option at that point. Oh, okay, because this already returns an option, so I don't need to worry about this. I was just wrapping it in tons of options. Okay, so we handled it this way, which is pretty equivalent to our, like, how we do it in something like JavaScript, like check if it's undefined, return, check if it's undefined, over and over. We could also do a bunch of if-lets because we're just passing this through. But there's also a bunch of other fancy ways to deal with this. Like we have and then. So we can refactor. And then only does something. If it's none, it just passes it through as none. Otherwise, it runs some function on the data. So we can do the same thing. And this still works. We're going to multiply by 10 again, but we can maybe do subtraction at this point. And this one looks a lot nicer. But it just lets us avoid all of those nasty code paths. We could just say, okay, do all this stuff if all these operations work, and otherwise just leave it, which I find very nice. Any questions there? I did a lot in that time.
Oh, no, you're totally good. Quick question. Would you be able to retrieve the value before the series of expressions finishes? Like, for example, you evaluate the first one, and then, well, when it's doing the multiplication operation, could you retrieve the value when it finishes after that, or does it have to finish the entire chain and then you can retrieve the value?
Oh, well, here's an and then where we're taking the value from the multiplication if it's successful.
Yes.
So we could take it out, but there's no way to know at this point without manually checking. So we could say, like, do many different things to get that value out. Like x.unwrap is one of them. But at this point, we haven't verified, and this could error. Unwrap throws an error if it's none. But we could do other things. We could do some default value, so like unwrap or 0. And now we default to 0 in that case. So we can take it out, but we still need to somehow check. The other one mentioned in the chapter is our if let. So like, if this value exists, do something, otherwise don't. So we do something in this case, which is similar to an and then. Or we have to match here, check it out, or we could do it in a pretty weird way. So like if x dot is sum, we could unwrap. And we know it's safe to unwrap here because we checked to see if it was sum. But we have better ways of doing this, like this pattern matching, that do all of this stuff on one line. Does that make sense?
Oh yeah, thank you. I was just wondering if, like, because of Rust's error handling nature, you wouldn't be able to retrieve the value. I was just wondering. Thank you.
Yeah, you can retrieve the value. You just need to make sure you know exactly what's in there, because it could be one of the two things. So you may as well. Well, not you may as well, like you have to in this case, because it's not very safe of you to say, okay, pull out the value. If you shouldn't be pulling it out. And just to point it out, Rust is not the only language with optionals. There's a lot of other languages that have it as well. I know C++, maybe? Is it C#? One of the C's has it, and it's had it for a while. Java has it. Swift has it, I'm pretty sure. There's a bunch of other languages that have this, and then obviously Haskell has it. Lots of functional languages have it. But I'm very glad that we are moving in this way, because I do not like doing type guards everywhere. And it's really nice to not have sentinel values anymore. Like if I have a function that tries to find something in an array, so like we do that real quick, like we have 1 2 3 4 dot find. So we find that we're gonna get an option back. So we find the value, great. I don't have to worry about, like in JavaScript, if we try to find something that doesn't exist, I believe it gives us undefined. So there's no need to think of a value where something doesn't exist. We don't have to do -1 if it's not in an array. It's just very nice. Any questions there?
You may have already answered this, but that and then chain, that will just push through a none if any of those resolve to none, right? 'Cause
Exactly.
it's like an and operation. Okay.
Yeah.
Cool.
It returns none if the option is none, otherwise it calls it on a function. And some just call it flat map.
Oh.
We also have option.map. All of the good functional stuff. Okay. Anyone else have any questions before I move on? I have one final example, and then we will be over with it, I promise. Okay. So, I'm gonna delete all this stuff. So we don't need it anymore. Just get rid of the clutter. So another good use of it is if we have another list of things. So something web dev related is if we have maybe color codes. So we could have a string for colors that holds a string, something like red, green, blue, any of the default CSS stuff. Or we could have RGB, which would just be a bunch of U8s. And here's the great example of why you should use an enum like this, because if you wanted a function that takes in multiple of these colors, maybe you have one that's even more similar. You have RGBA. We're gonna say it's a U8 at the end, but I'm not sure what the alpha is. I think it goes, if it's an U8.
It's a U8, yeah.
Okay. Is it like 0 to 100?
No, it's the same. It's
okay.
0 to 255, I'm pretty sure.
Perfect. So yeah, we can store all of these different things without needing a specific struct and a specific function to handle all of this stuff. So we can take in a color here and do something with it. And what do we think is a best case here if we intend to, I guess we don't know what the color is going to do, but what would be the best construct to use if we were just looking for this function takes in a color and then it prints it if it's a string? What would be the best construct to use here?
Match.
Why match?
Because it's an enum and matches like literally, like that's its purpose. It's to handle enums.
Okay, so we're gonna take this, handle all of these, and then we're gonna
Oh, what
do
was that autocomplete?
autocomplete. I didn't see any
It, like,
autocomplete. I just typed
auto-fill.
that fast.
Oh, okay.
No, it's fill
My bad. I
charms.
must have blinked. Yeah.
Bam. So we have this. We want to print it if it's a string, so let's print it. And then for these, we're just gonna do nothing. Return unit. Maybe it's better to do it like that, because we don't want to actually return what print line prints, we just want that. So you think match is good? Do you change your mind yet?
Now hold on. I mean, it depends on how complicated your implementation for each one is going to be.
Oh, we're
And
gonna
I
do
think it's
literally
still
nothing for
fine
the rest.
here. Yeah. Oh, you're not going to handle the others?
Oh no,
Then you'd
we're
probably
only
wanna-
doing this. This is the only thing the function does.
Okay. Then, yeah, you probably want to use an if let then.
Okay. And how would we go about doing that?
If space let, and then whatever your autocomplete is.
Whatever my autocomplete
Just do
is.
that. Just do that real quick.
Oh, no, my
I think
autocomplete
it's
broke. I turned off the LSP. What do I do?
okay. Okay. I think it's some.
Some?
Let me think. Oh no, it would be like whatever the value you want it to be. Shoot, I can't remember which order it is. I think you would do like some x or maybe some c,
Some X.
some x, and then that's equal to c, right? And so like the right side is is assigned to the left, basically. And so now you can use x like inside the if let. If the oh wait, I don't know how you would check, because you need to check if it's a string.
Oh no, this is the wrong enum.
Uh-oh. Oh, it's a color. Ah. Right?
Yeah, it's a color enum.
No,
So what would I put here instead?
you just put color instead of some.
I would put color. Are you sure?
Yeah.
Is some an enum?
I mean, some is an enum, but color.
Some is
also
not an
an
enum. Some's a variant of an enum.
Oh, it's a. Yeah. Because the option is the enum. I don't know how to get a variant from an enum. I'm sorry. Forgive me.
You use dot notation to check directly, or no?
Oh, maybe you use. I bet it's double colon.
It is double colon.
Or so you have an arm, or was that would be a reference?
Well, a dot is like a method, and then the double
Double colon.
colon is for like I guess it's like class-based references. So if you define like a function at the class level, not at the instance of the class, you would use double colon. And so I guess they use the same syntax here. I don't know if it's the same thing under the hood for both, but I've only ever seen the double colon syntax for the class like associated functions before, and enums.
Oh
Yes.
well, it is exactly like that. It's just in the prelude for everything else. So we could use it an option by saying
Oh.
standard. I don't know where it
Ah.
actually is, but we can type an option and find out. Because I don't know. Oh, it's in core. Oh yeah, it's just option.
Or option.
Core and standard are like the same thing as far as I know.
Oh, okay, cool. So that's
So
just
it's not
okay.
in
So
here.
it's just
It's in core. What? Okay.
what it was lowercase option, I think.
Oh, okay. Yeah, it's namespace to a module. Okay, understandable.
It was namespace under. Oh, okay. So,
option
namespace for
option is another namespace, and then option the enum is
Yeah,
the
because this is the yeah, like the enum itself. But if there's an impl, then that's in the same module most likely. So yep, we have this let I equals option of
Does that leading double colon reference the prelude or something? Or like what is that?
it just lets you use it without using a use statement because I'm lazy.
Oh, okay.
But it didn't work either way because so I probably did it wrong.
That's all right. I understand. What's happening now.
So we're gonna use this and delete this, and it's gonna tell me it's already imported, which is true.
Yeah, because yeah.
So option 32. Oh, that's why, because option is an enum. Wow, I'm so good at this. Okay, I figured it out. Here's the mystery solved. It's option sum, and then that is the variant. So we can say 32. And if we do that, this is just an extremely long way to not have to use a use statement. If you ever want to do that. Fun fact. And we can verify by going into here that this is just full of everything.
This is your tangent alert speaking. We should get back to that color example.
Okay, I left. Tangent.
That's my bad.
No.
Thank you for the reminder. Yeah. Thank you.
All right. To summarize, double colon is just for namespacing, or to get like an identifier. Cool. Thank you. Sorry about that.
Yeah, it's for associated functions and paths. So like we have different modules. Like if I wanted to use this in a different module, we don't have modules here. We'll get into that next chapter, I'm pretty sure. So we'll see more on double colon. But yeah, that is how you access variants of an enum. And yeah, I've let everyone off too easy this time. I'm gonna put at least one borrowing example in here, and you can't stop me. So now we're gonna actually just print out each color. Print everything. So now, what makes more sense? If let or match?
For each one?
Well, why are we passing in a single color? Are you trying to print every color possible, or I don't
we're
understand.
gonna take each one of these and then like print them out with like a different thing behind each one, because otherwise we could just debug print it. Otherwise we could just do this, and I don't
So
want
wait,
to do that.
so you mean if it's like an RGB or RGBA value, we want to print out each value individually?
Yeah, so if it's a string, we just write string colon that, like we print it out. We do, each one's handled a little bit differently.
So yeah, I'd probably use a match then if we're going to hit every variant of the enum.
Okay, we are filling those match arms.
Wow, you type fast.
Merge match arms. Find this. Amazing. So we want to print something different each time. So here we're gonna print this thing. Yay. We're not gonna do it because I don't want to spend too much time actually typing it out. But we are going to fill these ones out. Okay, so we're gonna use all of these, yay. But it's time to turn off the LSP and do the one and only borrowing, because enums also deal with borrowing and ownership because they are holding values. So if I do something like this, am I allowed to then print the color like this? Debug print. Will this compile?
I think no. I think the C is moved in the match. It might depend on the arm, like which branch though, like. But no, I think it moves into it. So like basically it moves C into like in the first one it would turn into S, and then in the second one it would turn into RGB.
It's similar to structs in the sense that you can move the whole thing, but they each interact with it differently based on what types are within.
Oh, can it automatically detect if every element in your enum is copyable or something? So like only the first one would move? Like if it was a string, it would move because it has to, but the others are all U8s, so they would just be copied.
We're not moving the whole thing though, we're just matching and taking the values out of it, so it's a little bit different. But yeah, on the right track. So which one of these arms would cause an issue and what would the error be?
Well, I think it would be the string.
Okay.
S, it would say it's moved C into S or something. And then if it was an RGB or RGBA, it would be fine because they would be copied.
Why is C moved though?
I mean, wouldn't it have to so that it can check the value? Like it has to basically like unwrap the value for you so you can get at the string.
Okay, we'll see. Wow, that's a lot of different things I'd run it with quiet. Okay, that does not ignore the warnings. I thought it would. It just ignores the output. I think it's because we actually, like, the to-do blocks it from doing anything.
It returns. Does the to-do return? Because there's no, oh, that's weird.
To-do doesn't return, it just tells the compiler that it's anything below is unreachable.
It says everything. Oh. I mean, it's basically like returning.
It returns never. I don't know if it's called never.
Oh.
Like the bang that we talked about
Okay.
before. So let's actually print something here. Or just like leave it. Let's print new lines. Okay, now let's see what this does. Oh, it actually tells you how to fix it. But yeah, the answer is it's a partially moved value, see? Because S is moved here. Versus if we have let X equal C. Then the whole value is moved. Because we're not actually moving the thing, we're just moving the values out from it because we're doing pattern matching fun. So how would we fix that? It does say in the compiler or in the output how to fix it, but there's like 3 or 4 different ways. Well, actually there's not 3 or 4, there's 1 or 2 that make sense. How could we make it so we are not taking ownership of S here?
You can make it a string reference in your enum.
So we could
So
make this a string slice here.
yeah.
That would cause a different error that we don't know how to fix yet.
Oh, we'll have to do like lifetimes. Dang it.
You can't use that answer right now.
I know, I know. Huh. Oh, we can just pass. No, never mind. Can you pass? No, you can't.
Let's say we're not changing any of this. We're leaving. The only stuff you can change is these highlighted lines.
The match.
You can only change the match statement, and the rest can't be changed.
Okay.
Well, you could probably change
What
this
if
too, but
what if we match on a reference to C?
What do you think?
Could you show the match statement again? Yeah, okay. It might be fine. I don't know if it automatically dereferences it when it like performs the match, but if it does, then it'll be fine.
It works. There's a bunch of warnings everywhere, but we're going to ignore that. I can do unused. I don't even know. Is that called unused? Oh, it's literally called unused. Okay. Yeah, it works. It's perfectly fine.
Cool. So it's the match statement isn't automatically dereferencing that reference you pass in, I guess, so that it can get the values.
You can see what happens here. So it takes our color and it implicitly moves the reference inside. So before we could have a color string, which is like pi to owned, or just string, whatever. We have a string in here, but it's implicitly making this a reference when you put it in front of here. Like if you tried doing this in a different way, this would not be possible. What the match does some magic for you. And one other way we could do this is with ref. And then that way you can set one of them to a ref.
What is that? What does the ref keyword do exactly? And why would you only do it to one? Because just the first one needs it.
Maybe you don't care about the other ones. You don't need ownership to them. And you want ownership given somewhere else.
But what does the ref keyword actually do there?
Pay attention to the type. Right now it is capital S string. And now it's a reference to a string.
And you couldn't just use like the ampersand there?
No.
Because
it doesn't want... Like this is a value and not...
Oh, it's not a type, I see.
It's not a type,
it's like
we
the
can't
name
just
of
do
the
it.
value. Yeah.
And we can't
It's
just
the name of
tell
the
it.
variable, not the type. Okay.
Yeah.
Cool. But you could manually type that, right? It would be like colon ampersand string, like it filled in for you, and that would work.
No.
Right. Oh. That's weird. Okay. Okay, okay.
You are not allowed to do that.
That's still kind of strange, but okay.
Yeah, so we try to do this otherwise. Without a match, it would be tougher because we have, I guess we don't have a reference here, so it'd be fine. But if we had a reference to something, it'd be hard to take something out. So like, let's say we had a reference to an option of color, and we want to deal with the sum or none case. If it's some, we're going to print let's debug. I don't know why I keep doing that, but we'll print X, otherwise we're going to do nothing for now. Oh well, understandable.
Oh, okay. So the ref keyword is a keyword specific for pattern matching.
Yep.
Okay. So you can just throw refs around elsewhere. It's like a pattern matching thing.
Does debug actually return something? I did not know that. Seems like it does. Oh yeah, it just passes the value through.
Yeah,
that's kind of cool.
It returns the value. That's how, yeah, because you can use it in line with pretty much anything, and
That's
it just
amazing.
returns the value out as well.
Like an inspect.
Yeah, it's cool, yeah.
That is great. Yeah, so we can do this here. Like we took this color out of an option and then implicitly moved the reference to the color instead. But if we try doing it in a different way, like some no pattern matching way, like let's say, let's just do it the brute force way. If C is some, and then we do C dot unwrap. Is that something we're allowed to do?
I don't know.
Nope, we can't move out of C because it's behind a reference.
Oh, I see. Okay.
Yeah, it's a reference to it, so we're not allowed to just
a reference to an
take it.
option of a color.
But if we do pattern matching, we get beautiful magic. Or we could do like as ref, and now it did the same thing. And moved it from a reference to option T to an option to reference T. But that tells you generally as well, it's typically more useful to have an option that you can directly handle versus needing to write as ref every single time you're going to deal with something like that.
Yeah, I don't know why you would want to pass a reference of an option, because usually when you pass an option around, it's like you're just passing the value around, and then when you need it, you unwrap it and handle whatever like options there are, basically.
I'm sure there's lots of good examples for...
Probably.
Let's see if any... Yeah, as dref takes in a reference. As ref. Clone. Yeah, clone makes sense. iter. I like all the mathy operations. Like we looked at and then, but XOR feels like, yeah, like I wouldn't know what that was, so I didn't know about and then. But yeah, I think we're probably good to end it off here. Any questions on this final example or anything that I went through?
Nope, I'm good to go. It's been very helpful with my understanding. Thank you.
Yeah, no problem.
Yeah, I think I'm good.
Okay, let's get into the homework real quick. Wow, that's a long chapter, or at least there's a lot of modules in here, or chapters. They're not chapters, they're sections, whatever they're called. But
Chapters all the way down.
we'll find out exactly
All the way down.
what the double colons mean and how to use modules, which is very helpful if you want to write a bigger program with more than one file.
Indeed.
And believe it or not, there's fancy autocomplete for creating modules.
Ooh.
Never make a file again on your own. Nice, okay.
Cool.
And the final thing, any feedback on anything? Anything you'd like to see that you didn't see? Anything that you really like seeing? General feedback?
I think it would probably be good to lead off with like some examples of option and result. Just like super pared down like a use case for each one that you can use to explain everything instead of like trying to like explain it abstractly first.
Okay.
Because I feel like the first example you had, what was it with?
It was with checksum.
Yeah, like a calculator, like or math operations. Like I think that was pretty good. So I think it might help just to like stick with a single example that used like the options and results just as like an example. So we're not like jumping between like bits of code, like when we switch to the colors and stuff. Just keeping it all in one like big example, I think would help.
Okay.
See, I think you did good about not getting too tangential this time.
Thanks for calling me out on tangent.
The tangent police. That's me. But yeah, pretty good overall.
Thanks. I think I did well with the amount of content, and I didn't really go through tons of examples like usual or try to force everyone to learn about the borrow checker. Only one example this time. But otherwise, I felt like that was a pretty approachable chapter in general.
Yeah, enums are awesome.
Cool. I'm gonna end it off there.